9.7 is solving systems with quadratic equations. Up to this point you have solved systems, but your systems have been both linear equations, and we had one solution, or we had infinitely many solutions, or we had no solutions if they were parallel. Well, now we're going to end up graphing a quadratic, which is a parabola, and a line, and we're going to see where they can cross. So the first method we're going to use is substitution. It does require 3 steps. The first step is you have to solve one of the variables, or one of the equations for one of its variables, either x or y. Next, you're going to use that revised equation and substitute it in to the other equation. Solve that equation for the variable you have left. Step 3, take that answer and plug it into step 1's equation. Let's go ahead and look at this. In this particular example, we do have it, and actually in both of these examples, we have them already set equal to y. So since they already equal y, we can set these equations equal to each other. So we're going right to step 2. And now we want to solve. Well, we have a quadratic equation here, and to solve it you have many methods. I'm going to go ahead and set it equal to 0, and then I'm either going to try to factor it, or I'm going to use the quadratic formula. So this is going to give me if I subtract 5 over here, it's going to give me a -6 equals 0. I'm going to go ahead and factor out a 2. That leaves me with x squared plus 2x minus 3 equals 0. This actually does factor. To get a -3 and a +2, I need a +3 and a -1. That gives me a product of -3 and a sum of 2. Now I set each of these factors equal to 0. So my x is going to equal -3, and my x is going to equal 1. Now remember, solution to a system, you get an ordered pair. We want to know what are the points where these lines or functions cross. So now I have to put this -3 back into either of these. I'm going to choose to put it in the line because I feel like there's less work for me to do there. So I'll substitute that in. And I might as well do it with the other value of x. Here I get a +12 plus 5 is 17. Here I get -4 plus 5 is 1. So my solutions are -3, 17, and 1, 1. So if we were to graph these functions, we would see that they intersect at these 2 points. And we're going to go ahead and look at the graphs in a little bit. Let's try this one. So we have them both set equal to y, so we can set them equal to each other. I'm again going to set it equal to 0 and see what I get. So I'll subtract the x to give me a 1x, and I'll add the 2. I'm going to take my chances again and try to factor it. So I'll factor out a negative. And it does look like it's going to work for me. To get a -2 product, I need a 2 and a 1. I want a -1 and a -2 and a +1, because that'll give me a -1 for the sum and a -2 for the product. So we have x minus 2 equals 0, and x plus 1 equals 0. So x is going to equal 2, and x is going to equal -1. Again, we plug them in to find the y value. So y is going to equal 2 minus 2, or 0. Y is going to equal -1 minus 2, which is -3. So my answer is 2, 0, and -1, -3. And I have put this on Desmos so that you could see it. So here it is on Desmos, and notice all I did was in my y1 equation I just typed in the -x squared plus 2x, and then the second one I typed in y equals x minus 2, and they're crossing here at 2, 0, and they're crossing here at -1, -3. Alright, so here when we graph a system of equations, the graphs again intersect at each solution of the system. For a system consisting of a linear equation and a quadratic equation, you can get different numbers of solutions. Here's an example of where we have no solution. This parabola is not going to dip back down, and the line is not going to curve up, so there's no solution. They're not intersecting at all. Or we can have one solution where the line is called sort of being tangent. You'll learn about tangency in geometry. But the line is only intersecting it in one spot. It kind of just skims it. And then you have two solutions like the last two that I did for your examples where they intersect in two separate spots. I have no idea what just happened here. Okay, technical difficulties. What we're going to do now is we're going to use the graphing calculator. So yes, you do need Desmos. We're going to use the graphing calculator to find the points of intersection here, if there are any, of the graph of the system. So this is kind of nice that we have the graphing calculator online to do this. So I want you to go to Desmos. And in the first equation, I want you to type in y equals 2x, down here's the squared, minus 7. And then in the second equation, we'll type in y equals 2x plus 5. And we can see here, there's going to be 2 points of intersection. I just have to scroll. And I'm going to click right here and right here. So my solution is negative 2, 1 and 3, 11. So this is kind of nice. We just go back here and I just put that my solution is negative 3, 1 and no, it's not. It's negative 2, 1. How quickly I forget. And 3, 11. So now let's go back to Desmos and we will do the next. So we have y equals negative 4x squared plus 2x plus 1, and then we have y equals 10x plus 1. And we can see by the picture it's only going to intersect, I think, in one spot. If we look at this and you keep going out, it's only intersecting right here at 0, 1. So our solution is 0, 1. All right, next. Solve the equation using a system. Solve the equation using a system of equations. So when you solve these quadratics, we're only looking for the value of x. So when you do this, you have to set each of these equal to y. So y equals x plus 3. And the other side of the equal sign, y equals 2x squared plus 3x minus 1. Now, I'm just going to go ahead and throw these into Desmos because Desmos is my good friend. And we're going to see what the x values are for this particular function. Alright, so I put them in here and they intersect right here and right here. So my solutions, I'm not looking for the solution of the system, I'm looking for the solution of the equation. Remember, we're just solving this original equation for the x. So my x value is negative 2 and my x value is 1. Negative 2 and 1. So that's all I have to write. So x equals negative 2, x equals 1. If you were to set this to 0 and either factor it or do the quadratic formula, etc., these would be your two values of x. Let's try it with these next two. So we have y equals x squared plus 7x plus 4 and y equals 2x plus 4. So let's go to Desmos and type those in. Alright, so I typed them in. And notice I just discovered something. I don't even have to put y equals up here. I can just type in what those functions are. And my answer is going to be 0 and negative 5. Again, I'm only looking for the x values because ultimately I'm solving the one equation. I'm just doing it using a system. So my answer is 0 and negative 5. So kind of cool. This one looks a little different. So let's try this one. Negative x plus 4 and y equals 3 to the power of x. Let's see what this one ends up looking like. Remember to do the power of, we're going to go to the a to the b and then just hit in the x. So here I can see it's going to intersect in one spot. This, recall, is an exponential function. So we're not using quadratics right now. We're looking at a line and an exponential function, but we can still see then my x value is 1. So my answer here is just 1. So x equals 1. And now, if you're a little skeptical, what you can do is you can check this. I have negative 1 plus 4 should equal 3 to the 1. That's 3, and this is also 3. So it does work. All right, I've got a couple story problems for us here. Toby's riding his bicycle in a large park, following a path that can be modeled by the equation y equals 2x squared minus x plus 3. Cecil is also riding his bike in the park, followed by this following equation, y equals 7x minus 5. Do their paths intersect? If so, what are the coordinates of the points where their paths intersect? So I'm going to look at this equation and this equation. They're both set equal to y, so I can set them equal to each other. And they're not asking me on here to use any particular method, so I'm going to go ahead and use my graphing calculator because I can. And it does appear that they're going to cross right here at 2, 9. They're only going to cross in one spot on the path, but they're going to cross at the coordinates 2, 9. So at what coordinate point? 2, 9. And we're done. Last one. Carmen's hat was blown off her head by a sudden gust of wind. The wind is pushing the hat away from Carmen, following a path that can be modeled by this quadratic. Carmen races after her path, it looks like in this straight line. Will Carmen catch up to her hat? That is the story of the day, the question. So x squared plus 2 equals x plus 1. Let's go ahead and see if Carmen is going to catch her hat. Unfortunately for Carmen, it does not look like she's going to catch her hat, because if you look right here, the straight line is never going to catch the parabola. So unfortunately, no, she will not catch her hat. And no, the functions do not intersect. That's a CT. Okay, so that is it for lesson 9.7. Here's your assignment if you'd like to work on it. 9.7. This is page 625 to 627. Problems 4 to 32 even, and 34 to 37. You must follow the directions. So if it says you have to use substitution, you can check it on the calculator, but you cannot just get your answer on the calculator. You're going to have to show me some work. So have a good time.